Hello viewers, a very warm welcome back to Reflux. In this video, I am going to discuss the detailed video solutions to questions that came from subject Power Electronics and get to know electrical engineering. Basically, 6 questions came from Power Electronics, 2 of 1 mark and 4 of 2 marks, total 10 marks, which were of moderate to difficult level. In this video, I am going to start the detailed video solution question number 27, which is 1 mark MCQ type, as you can see. From subject Power Electronics, based on input power factor. Question number 27, the master question of get to know electrical engineering from subject Power Electronics is as follows. It is given the input voltage V of t and current I of t of a converter are given by V of t equal to 300 sin omega t volt, I of t equal to 10 sin omega t minus pi by 6 plus 2 sin 3 omega t plus pi by 6 plus sin 5 omega t plus pi by 2, but omega equal to 2 pi into 50 radian per second. The input power factor of the converter is closest to, and the options are given as A 0.845, B 0.867, C 0.887 and D 1.0. So let's move on to solutions question. Pretty simple question based on input power factor. Okay. Converter is given. Converter current, voltage and current is given. Right, as you can see. Now, to find the input power factor, we need to first know definition of input power factor. क्या होता है definition? देख लेते हैं पहले. Input power factor, abbreviated as IPF, is given by displacement power factor abbreviated as DPF into current, also called DF sometimes, displacement factor or displacement power factor, to current distortion factor. CD. Displacement power factor is nothing but the cos phi 1. It is the difference, the cosine of the phase angle between the fundamental voltage and the fundamental current. In this case, as you can see, omega t and omega t minus pi by 6. So pi by 6, so phi 1 here in this case is pi by 6. Okay. So phase angle between the fundamental voltage and current components, fundamental frequency, voltage and current components. And as you can see, we have to need also another factor which is current distortion factor, CDF. Current distortion factor क्या होता है? ये तो हो गया आपका DPH, जैसे आपका हो गया V1 I1 cos phi 1. Of course, RMS values. CDF क्या होता है? CDF हो गया current distortion factor, मतलब this is the ratio of the RMS value of the fundamental component of the current to the total current RMS value. इधर कितने components है RMS current waveform में? Fundamental frequency, third harmonic and fifth harmonic. So there are 3 in I1 RMS, only the RMS value of fundamental frequency, that is 10 by root 2 will appear, and in the denominator we have the RMS value of the total current waveform, which is under root 10 by root 2 square plus 2 by root 2 square plus 1 by root 2 square. Right, 10, 2 and 1 the coefficients, the amplitudes, the different frequency components. So fundamental RMS by total RMS, we get what? We calculate it, root 2 cancels. Right. So we are left to 10 by root 100 plus 4 plus 1, that is 10 by root 105. Okay, or also you can get it as simplified and get it to 20 by 21. I'm not calculating the values, you can directly put it in the virtual calculator. virtual calculator सीधा पुट करने से इसका आंसर निकाल सकते हैं, वैल्यू निकाल सकते हैं. डीपीएफ निकाल लेते हैं तो सीडीएफ निकल गया हमारा. डीपीएफ कैसे निकलेगा? बहुत ही आसान तरीके से निकल जाएगा. V1 का फंडामेंटल आरएमएस कंपोनेंट क्या है? 300 मैक्सिमम वैल्यू तो 300 by root 2. I1 क्या है? 10 by root 2. 10 मैक्सिमम है तो 10 by 2 उसका एम्पलीट्यूड by root 2. And cos phi is what? Cos of pi by 6, that is root 3 by 2. This is root 3 by 2. So you put the values, you get dp will have only this, only cos phi. You will get the power, fundamental power in this case. So simply we have to put here, simply we have to put here cos of pi by 6. This displacement power factor is cosine of the phase angle between the voltage and fundamental voltage and fundamental current. So it will be cos of pi by 6. That is the phase difference, phase angle. So cos of 30 degree, which is root 3 by 2. So the input power factor we get it as dpf, that is root 3 by 2 into cdf, the current distortion factor, that is 220 by 21. You can put this in the virtual calculator and you will get, I think, this cancel 7, I think root of 5 by 7. So I think the value comes up equal to square root of 0.714. This is approximately comes out to be, I think, 0.845. So to calculate using virtual calculator, you can put this in the virtual calculator. After simplifying root 5 by 7, square root of 5 by 7, I think we will get close to 0.845, which exactly matches option A. So the correct answer for this question is option A. That is the input power factor of the converter for the voltage and current waveform equations are given, V of t and I of t respectively, is 0.845. Is option A. Correct answer for this question is option A. Our solution is clear and comprehensive. If you still have any doubts or queries, please ask in the comments. And that's all for solution to this question. Thank you. Moving on to the next question in the series of GATE 2025 electrical engineering solutions from subject power electronics. Next question is also 1 mark, numerical answer type, NAT. Question number 34 in the master question paper GATE 2025 electrical engineering from subject power electronics is from basically power MOSFET and power electronic power semiconductor switches. Question goes like, question number 34, the master question paper GATE 2025 electrical engineering from subject power electronics. In the circuit with ideal devices, the power MOSFET is operated with a duty cycle of 0.4 in a switching cycle with I equal to 10 ampere and V equal to 15 volt. The power delivered by the current source in watt is dash, round off to the nearest integer. So we need to calculate the power delivered by the current source in watt, the nearest integer. Right? Round off to the nearest integer. Let's move to solution. Solution पे आगे बढ़ते हैं. सिंपल क्वेश्चन है, सब देख सकते हैं. तो बेसिकली इस पावर MOSFET is given that power MOSFET is operated with decided that is D equal to 0.4. So in a switching cycle, let the time period be switching period be T. So for dt time, that is 0 to dt 0.4 duty cycle, that is during this time the switch will be closed. the effective circuit becomes like what? Switch closed means this is an ideal power MOSFET, so it will be short. This gate voltage is given for this time period 0 to dt, short like this, and diode will be open like this, right? Short means the voltage across the current source is what? 0. This voltage is 0. So the power delivered to the current source will be what? Power delivered, let's say energy, power delivered also, or energy delivered V into I. This V, not this V, but this is VI. So VI into I, that is 0 in this interval, because it is short. Across the current source there is no voltage, voltage नहीं है current source के across, तो इस डिविजन में ये हो गया 0. The switch closed है, power MOSFET, switch means power MOSFET here, power MOSFET on. Okay, ये तो एक टाइम हो गया 0 to dt. Now another, there will be another interval which will be dt to t, for which the power MOSFET will be off. It is 0.40 here. It is 0.40. D is given as 0.4. So 0.4, 0 to 0.40. Switch closed. Power MOSFET on. So power delivered is 0. There is no voltage across the current source. And for dt, t between tt and t, that is 0.40 and t, power MOSFET is off. That is switch open. Switch open means what? The current source and the diode becomes short because the current is being conducted in this direction, so this effectively short circuits the diode. The effective circuit will be what? This, like this. So VI will be what? Voltage across the current source will be same as V. It is 15 volt. Right. So the power delivered during this time will be what? VI into I, that is V into I, that is 15 into 10. 15 into 10. That is 150 watts. But this will be occurring only for the time interval between dt, that is 0.40 and t. For the remaining time, the power delivered will be 0. So we need to find the average power, right? Average power. Power delivered unless otherwise mentioned, अगर कुछ नहीं दिया हुआ है तो average power ही मीन करता है. Average power in this case will be what? Delivered the current source. Energy by time, you have complete cycle, right? For this time interval 0.4 to t, what is the time interval? Energy will be what? Power into time. So 150 into time interval is 0.4 to t, that is t minus 0.4t. The total time in a complete switching cycle is, switching period is t, into time is t. Right? ये होगा, ठीक है? So 150 into 0.6 t upon t. T cancels out, 150 into 0.6 gives 90. So the power delivered by the current source, average power delivered by the current source, that is PI, we have calculated to be 90 watt. Because the answer is asking what power delivered to current source in watt. The correct answer, nearest integer, it is already an integer, so it will be 90. Right? As you can see clearly. So we solved it with the very basics of the power MOSFET, the switching device. When it is on, then it will get short circuit, so the voltage across the current source is 0 and there is no power delivered to the current source. When it is off, the switch is open, that gets short, and this is the resultant circuit. So the average the power delivered during that on switch open or power MOSFET off condition is 150 watt. The complete cycle, we then calculate the total energy and divide with the switching time period, this t, and we got the Average power delivered by the current source is 90 watt. The solution is clear and comprehensible. Very basic. I have tested on the very basics of the switching power semiconductor devices and power MOSFET. I hope the solution is clear and comprehensible. I have tried to explain each and every step, both the conditions to derive and obtain the final answer is 90 watt. So that's all for solutions question. Thank you.
Moving on to the next question. In this video, we will detail solution to question number 46 from bioelectronics subject. I will get ready 2 marks and execute. The question goes like: the three-phase modulating waveform VADT VCT is determined by voltage source inverter VSI or VA of t is 0.8 time volt, VBT equal to 0.8 time omega t volt, VCT is 0.8 time omega t plus omega t volt. So when you are triangle theory of magnitude directly plus 1 and minus 1. Option A. मुझे इस which clear doubts or queries. Just in solution. Let me know in the comments. And that's all for solution this question. Thank you.
To 50. One by L integration v dt dt, right? So I of t equal to, if you put this So it will be what? Acha, when we replace with sin theta, then this will be replaced with denominator. Because we have replaced omega t by theta. So one omega term will come here. So it will be what? 23 root 2 by pi. Correct? Okay. Sin theta integration is minus cos theta. And after that we can replace theta with 2 pi into 50t plus constant. Now to find the value of the constant, हम लोग क्या करेंगे? We find the initial condition. Initial condition is before the cycle is just switch, the inductor current was 0. So I of 0 equal to 0. We put t equal to 0 here. Then we get what? Cos 0 is 1. So C become I of, we put I of 0 equal to 0. We get what? I of 0. This term was minus 1. So C minus 23 root 2 by pi equal to 0, or C equal to 23 root 2 by pi. So the current equation, we put the value, we get I of t equal to 23 root 2 by pi 1 minus cos of 2 pi to 50t. राइट, बहुत ही आसानी से हम लोग ये एक्सप्रेशन मिल जाता है करंट का. सही, दिस इज द एक्सप्रेशन फॉर करंट 23 root 2 by pi into 1 minus cos 2 pi into 50t. So the maximum value will be, cosine varies from minus 1 to 1. So the maximum value will be obtained when cosine this function is minus 1, and the maximum value will be I max equal to 23 root 2 by pi into 1 minus minus 1. When this becomes minus 1, this will be maximum. The value will be 46. 1 minus minus 1 is 2. 2 into 23 root 2 is 46 root 2, and there will be pi I max. Now इसका ग्राफ हम लोग बना सकते हैं देख के. When it was, when at t equal to 0, this will be 0, and when t equal to pi, this will be a maximum value. Right? So somewhat it will be like this. This will be 46 I max value, which is we calculate as 46 root 2 by pi amperes. ठीक है? Like this, 0, 10. Yeah. Milliseconds and I in amperes. This is I of t. If you draw the graph, this will be somewhat like this for the inductor current, and the expression will be this 23 root 2 by pi into 1 minus cos 2 pi into 50t. And using this, we find the maximum value of the inductor, peak value of the inductor current as 46 into root 2 by pi amperes. We put this in the virtual calculator. I think you will get the value as closest to 20.71, if I am not wrong. You can try it out and put this in the virtual calculator. Get it nearly as 20.71 amperes, which matches option A. Peak of the inductor current in amperes is 20.71. So I will explain the solution in detail on the very basics. We find first drawing the voltage and current waveforms, and finding the expression for current, inductor current, and then finding its maximum value. Hope the solution is clear and comprehensible. If you have any doubts or queries, please feel free to ask in the comments. And that's all for this simple question. Thank you. Hello viewers. Moving on to the next question in the series of GATE 2025 electrical engineering solutions from subject power electronics. The next question, question number 48 in the master question paper of GATE 2025 electrical engineering from subject power electronics, is also 2 marks MCQ type. It is from basically from converters. Right. And the question is given as, in the following circuit the average voltage is V0 equal to V0 equal to 400 into 1 plus cos alpha by 3 volts. Right. And where alpha is the firing angle, as you all know, of this converter. If the power dissipated in the resistor is 64 watt, then the closest value of alpha in degrees is, and the options are given as A 35.9, B 46.4, C 41.4 and D 0. Let's move on to solution for this question. Solution to algorithm. Pretty simple, basic, fundamental. It is given power dissipated in the resistor. This resistor of 1 ohm is 64 watt. Power dissipated in the resistor, the average value of the voltage across the resistor is, say, VR. And the power dissipated across the resistor is VR square by R, which is VR square by 1 in this case. It is given as 64. So VR we get as what? Square root 64, that is 8 volts. Now since this is the average voltage, क्योंकि average voltage है, इंडक्टर क्योंकि एक कंजर्वेटिव एलिमेंट है, इसमें उसको पावर डिसिपेशन नहीं हो रहा, एनर्जी इज कंजर्व्ड अक्रॉस द इंडक्टर, सो द एवरेज वोल्टेज अक्रॉस द इंडक्टर इज 0. तो इसके अक्रॉस एवरेज वोल्टेज अक्रॉस द इंडक्टर वी नीड नॉट कंसीडर. सो बेसिकली V0, द आउटपुट वोल्टेज इज द sum of this VR plus VL plus 500 volt. This voltage source. Now the average voltage across the inductor is 0 and average voltage across the resistance is 8 volt, already calculated. So 8 plus 500, that is 508 volts. Correct? सही है. Now this V0 value, the average voltage was given as in the form of alpha. The function of alpha is this. So you can equate this value with the one given. So what we get? 400 into 1 plus cos alpha by 3 equal to 508. So if you simplify it, this will cancel 1.27. So from here we get 1 plus cos alpha by 3 is equal to 1.27, or cos alpha by 3 equal to 0.27, take 1 to that side, or cos alpha equal to 0.27 into 3, that is 0.81, right? So we get the firing angle alpha as cos inverse 0.81. We know that the value of cos inverse 0.8 is 36.87 or 36.9 like that. So as alpha cos theta is it decreases with the increase in theta. So cos inverse 0.81 will be slightly less than 36.7. That is, among the options we can easily find out that it is 35.9, close to 35.9 degrees. Right. As cos inverse 0.8 is close to 36.79 degree, so cos inverse 8.81 is slightly less than that, 35.9. Other options are nowhere near, कहीं भी नजदीक नहीं है बाकी options. So the correct answer to the question is option A, 35.9, as the alpha is asked in degrees per angle. So I hope the solution is clear. I approach this question with very basics. We first finding the using the power dissipated across the resistor to find the voltage across the average voltage across the resistor, right, which we have obtained as 8 volt. Next, the average voltage across the inductor is 0, as the inductor does not store any energy in every cycle. Next, the total the output voltage will be sum of inductor voltage, resistance voltage across resistance, and the 500 volt. So we get that as 508 volt. we put it to the given value of the V naught given, and we find the value of alpha is 35.
Hello viewers, moving on to the next question, the last one in the series of gate power electronics. Because 2 marks, electrical engineering, power electronics from basically DC buck converter. Question given, the steady state capacitor current of a conventional DC-DC buck converter working is shown in one switching cycle. If the input voltage is 30 volt, the value of the inductor current in milli-Henry is round up to 1 decimal place. Basically, and the waveform given the state calculator of a conventional DC buck converter. Let's move to the solution diagram. Let's draw a buck converter. The buck converter is the conventional DC buck converter operating working city. That is the inductor current does not become zero at any instant. It continuously goes with, there is very two extremes which are IL max and IL min, where IL min is greater than zero. IL minimum value I to delta now. Okay. We apply KVL. We get okay. Now the inductor current increases when the fluid flow. Because it is the increasing part of the current, the capacitor current, is same as that of the inductor current as the output current is constant. Last one 0 to 50 between 30. So 30 microseconds. Increasing current. So decreasing current for another till 30 to 50. So the total increasing part, so 30 and the total cycle is for using is for 50 microseconds. Only the increasing part, the switch remains closed. Right? So the duty cycle, the period for which the original increases. So the inductor current also increased. The model is 30 microseconds when total switching time, which is 50 microseconds. Okay, fine. Okay. Right. So when switch is closed, we have to look KVL Vn minus L delta I L by dt minus V0 equal to 0. ठीक है बेसिक केवल यूज दिस नाउ V0 को मैंने D into B to D to get here B into 1 minus D equal to L delta L by dt ठीक है राइट नाउ to put the values in the question V is given 30 volts input D was calculated to 0.6 active 1 minus L need to calculate the value of the inductor and delta A is what is calculated as point delta E not is zero is not revealing the load current. I need to find what is the time for the flow dt 30 minutes. Right? So this is the distribution. Let's solve it here. T into 1 minus point is 0.4. 0.4 is 30, 12. So set it in the analysis. 0.2 by 30 microseconds. Means what? 1 by 150 microseconds. So we can take it like 30 to 0.2 into 30 to 0.4 which is 12. Put the value calculate you get what? 31 into minus 2 mg or it divided with 1000 it is nearly 1.8. So the inductor value value of the inductance is 1.8 mA for the given steady state form of the conventional electricity continuous current continuous conduction mode. 30 volts. Right? Answer for the value of the inductor is 1.8. Right? Out of 150. So let's get to one surface. No one also required. So let's explain how to obtain the value of the inductor from very basic. We explain the operation of the conversion buck converter heat treatment. For which the minimum inductor current is greater than the leveling capacitor bank is still inductor current. If there is no leveling the output current, go to the output which will be constant. From that we calculate the inductor current from the leveling capacitor bank waveform here. Using that also capacitor bank increase on the load. So calculate that also. For what part of the cycle is closed, that is responsive. Now we have to go to point D for fixing operation, that was doesn't move. So put the value and finally you obtained the return value 120 million. Correct to 1 place. So basically, I explained all the steps in detail along with the working on the converter. Hope you understand it. Yes. So that's all for this question. If you have also guys, please ask me comments. Not only for this question, but other questions as well. Hope it helped, really helped understanding. And that's all the question and also the subject for difference. Thank you.